Next, we're going to look at evaluating some of the reciprocal inverse functions. Before we do that, let's just remind ourselves, we know that the inverse sine gives us output values in quadrants 1 and 4. They end up being angle measures in quadrant 1 and 4. The inverse cosine gives us angles from quadrants 1 and 2, and the inverse tangent gives us angles in quadrant 1 and 4. Now, just a quick reminder, the angles that we get in quadrant in quadrant 4 for the tangent and the sine are negative angle measures. They're angle measures between 0 and negative pi over 2. So when we look at the reciprocal functions, the inverse cosecant, inverse secant, and inverse cotangent, the inverse cosecant and inverse secant, the angles that they're restricted to and the values that we're going to get in the output are going to be the same as their reciprocal functions. So the inverse cosecant is going to give us outputs in quadrant 1 and 4. The inverse secant is going to give us angle measures in quadrants 1 and 2 as their output. However, the cotangent's a little different. The cotangent is the only inverse function, right? We can see this note here. The cotangent is the only inverse function who's defined in a different quadrant than its reciprocal. So the inverse cotangent is going to give us angle measures in quadrants 1 and 2. And that's because if you think about the cotangent function, the graph of the cotangent function, its first cycle is graphed from 0 to pi radians, which are just the angle measures from quadrants 1 and 2. So that's why it's defined in those two quadrants. So let's use this fact to help us evaluate some inverse functions of the reciprocal functions. So we want to find the exact value of the inverse secant of 2. Now, I'm not very good with my values of the secant, so I want to kind of think about this in terms of a function that I'm more familiar with. I'm much more familiar with the inverse cosine. So we want to change this into the inverse cosine. But in order to change this into the inverse cosine, we have to take the reciprocal of the argument. Now, this works out okay because we know that the inverse secant and inverse cosine are going to give us outputs of angle measures in the same quadrant. It's going to be in quadrants 1 and 2. Now, because this argument is positive, that tells us that our value of theta, is going to be in quadrant 1. So remember, this just means for what value of theta is the cosine equal to 1/2. Well, if you think about the measures on the unit circle, the cosine is 1/2. Remember, the cosine is the x when the ordered pairs are 1/2 comma rad 3 over 2. And this happens at an angle of theta being pi over 3. So at pi over 3 radians, this is true. So that means that the secant inverse of 2 is going to be pi over 3, which is the same as the cosine inverse being 1/2.